This is 2010 FRQ number 1. This is in the calculator section. All right, so there's no snow on Janet's driveway when the snow begins to fall at midnight. From midnight to 9 a.m., snow accumulates on the driveway at a rate modeled by f of t equals 7t e to the cosine t. So remember, this is a rate at which the snow is falling from midnight to 9 a.m., where t is measured in hours since midnight. Janet starts removing the snow at 6 a.m. The rate g of t in cubic feet per hour at which Janet removes snow from the driveway t hours after midnight is modeled by this function right here. So this is removing. So this is snow falling. This is removing of the snow. Part A says, how many cubic feet of snow have accumulated on the driveway by 6 a.m.? So this is only asking for snow accumulation, so that we take the rate, and if we want the total amount that's being accumulated, we then take the integral of that. So for part A, you take the integral starting at midnight, that's our 0, to 6 a.m., that's 6 hours, of our function 7t e to the cosine t dt. All right, you punch this in the calculator. So let's see. Again, I'm going to go math 9. My function 7x e to the cosine x. All right, comma x, comma 0, comma 6, close parentheses. Always double check I'm in the right mode, radian. Okay, enter, and I get a snowfall of 142.275 cubic feet. All right, so 142.275 cubic feet. All right, that's it for part A. Part B then, find the rate of change of the volume of snow on the driveway at 8 a.m. So the rate of change, you want the change in the volume, right? So you want to change, you want the derivative of V, right? And that is the rate at which, because at that point she's already starting to take away some of the snow. So you want the rate at which the snow is falling minus the rate at which she is taking away the snow. Then that's the change in the volume, right? Because you're taking the rate at which it comes down minus the rate at which you're taking it away. That's the change in the total volume of the snow. So f of 8, you plug in 8, that is 7 times 8, 56, e to the cosine of 8 minus, well, g of 8 between 7 to 9, that will give me 108. So you punch it all in the calculator. So this is a fun one. So 56 e to the cosine of 8. This is why your mode has to be very, has to be in radians. That's why it's important, right? Minus 108. And I get negative 59.58. So negative 59.583 cubic feet per hour. That means she is actually taking away more snow than the snow is coming in. That's why the rate is negative. That means our volume is decreasing. Okay, very good. Part C, let h of t represent total amount of snow in cubic feet that Janet has removed from the driveway at the time t hours after midnight. Express h as a piecewise function with a domain between 0 and 9. Okay, so h of t, this is the rate at which this is happening. Now we want the total amount she's done from 0 hours to 9 hours. So for part C, you need to kind of look at it a little bit in terms of the rate at which she is taking away the snow and how much time has passed. So in h of t, all right, you have 3 intervals because you have 3 intervals here. You have between 0 to 6, and then 6 to 7 hours, and 7 to 9 hours. Well, we know in the first hour, in between 0 to 6, nothing happened because she didn't start removing the snow until 6 o'clock. So this is 0 for the first one. That one's nice and easy, right? All right, well then the second piece, she's working at 125 cubic feet per hour in this hour between 6 to 7 hours. So what is the rate at which this is happening? And you can't, you don't know what time you're looking at. So this is a function that this is happening. So in other words, you're saying that you are taking the snow away between 6 to t, and t has to be less than 7. And the speed at which this is happening is 125 dt. And if you recall, there's a constant, it's 125 times b minus a, so t minus 6. So go and clean this up. That's 125t minus 125 times 6, that's 750. All right, so this is the first equation for the first piece. This is the equation for the second piece. All right, now at 7 hour, so right before the 7th hour, right at the 7th hour, you already took away 125 because that is the speed at which that happened, right? And in that 1 hour, right, in that 1 hour, that's the speed you worked at. So in that hour, you worked 1 hour times 125. That's why you already took away 125 cubic feet. And now you're gonna take away more. You're working a little slower now. You are taking away 108 cubic feet per hour between the hour 7 and 9 hours. So in the next 2 hours, you're working a little bit slower. So it's gonna be 7 to t. Again, the t is gonna be less than 9 hours at the rate of 108 dt. So that's 125, that's the first piece, right? Plus 108 times b minus a, t minus 7. And if we clean this up, we get 125 plus 108t minus 7 times 108 gives me 756. So if we clean this up, you get 108t and minus 631. So h of t, to rewrite it in piecewise function, these are my functions. These are my 3 pieces. H of t equals 0 for between 0 to 6 hours. And then what is going to happen? Well, the amount, nothing happens at 0. So this is going to happen. So it's going to change a little bit because at the end of the hour, you have the full volume at the end of that hour, and it changes to the next hour. So that's why our restriction is going to change a little bit here, right? So the next piece is 125t minus 750 between 6 and 7 hours, and then 108t minus 631 between 7 hours to 9 hours. All right, and that's our piecewise function for part C. Okay. Part D, let's see. How many cubic feet of snow are on the driveway at 9 a.m.? So at 9 a.m., snow has already fallen for 9 hours, and she already started taking away. So she started taking away at 6 a.m., right? So that's quite a lot of stuff happening. So how much snow is there? How many cubic feet of snow? So we start with how much snow we have. Well, we have snow. We have between 0 to 9, 7t e to the cosine t dt minus how much snow was removed, the total amount that was removed, right? Because this was the rate at which this is happening. So how much is removed at the end of the 9 hours? H of 9, right? So plug this in the calculator. We get 367.3346. And then if we use this formula, we get 108 times 9 minus 631, right? In the end, at 9 hours, at 9 a.m., we have 26.335 cubic feet of snow at the end of 9 a.m. Okay?